And this is a question from redox reactions, the concept of law of equivalence. See here, the question is given like this: the number of moles of ferrous oxalate and ferrous sulfate ammonium sulfate dot 6, this is a Morse salt required to completely react with 2 moles of the acidified KMnO4 for each of them is respectively. Here we have to take acidified KMnO4. So in this particular case, we can use the law of equivalence. According to law of equivalence, the gram equivalence of ferrous oxalate should be equal to what? Gram equivalence of KMnO4. Here no need to balance the reaction, just we can take the equivalence of ferrous oxalate is equal to equivalence of potassium permanganate in acidic medium. So here gram equivalence, your question they are asking in terms of number of moles. So we can convert the gram equivalence in terms of moles, that is number of moles of the particular substance into its N factor, that is for in this particular case ferrous oxalate, and similarly the gram equivalence of KMnO4, again this is number of moles into N factor of KMnO4. So what are the number of moles we have to identify for ferrous oxalate, and again what is the N factor for ferrous oxalate? So ferrous oxalate N factor is 3. Then how to identify the N factor for ferrous oxalate? Here you can see the ferrous oxalate here. So it will oxidizes in presence of KMnO4. Why? Because KMnO4 is a strong oxidizing agent. It can oxidize the ferrous oxalate too. So in a ferrous oxalate iron, it is in plus 2 oxidation state, and that will be oxidized to plus 3. And similarly we have the oxalate is oxidized to carbon dioxide, and here carbon oxidation state is plus 3 and oxygen is minus 2. And here there is no change with respect to oxidation state of oxygen, only iron and carbon, both the elements, their oxidation states are going to be increases. Here iron oxidation state is changing from plus 2 to plus 3, and whereas carbon oxidation state is changing from plus 3 to plus 4. Now we have to identify the total change in oxidation state with respect to iron, and so this is this Fe, F2 gave here, it is Fe, sorry this is not 2,